Hi everyone. So hopefully you got a sense from the last video that the faceting that we're able to do in OpenRefine gives us a really useful way to start generating some quick insights about even a large data set. So in this case, for example, I might say, well, across this 100,000 data, across these 100,000 rows of data, I want to see, for example, how prevalent. I'm going to go ahead and come back to selecting all of my data. I want to say something. I want to see something about, I don't know, how common subscribers versus customers are. So happily, there's actually some metadata on the landing page about, if you come back here, about what these things mean. So a customer is somebody who has a 24 or 3-day pass. A subscriber has an annual membership. So one thing that we can see again right off the bat here is that subscribers compose 80%, over 80% of the rides taken in this time period, right, in this first 100,000 rows. And I could facet them before, and I could say, okay, you know, among subscribers, what is, say, the gender breakdown? Right, I can still do a text facet on this and say, okay, interestingly, you know, of subscribers, roughly 60% of them are men, 20% of them are women. There's a small percentage that haven't identified. So you can see how we can start building narratives and understandings if I wanted to say, look at them from a particular start station ID, right? Maybe I want to look at this by neighborhood or something. I could go ahead and make a selection there and see how all of these things are impacted, right? So as I choose subsets of information, what I get is actually the narrowed count, the combination of all of these things. And I can start to make, generate some questions and hypotheses about this data set. So that's one way that we can manipulate this data. There's another really important thing that type of data manipulation that OpenRefine supports, and those are called regular expressions. Regular expressions are a kind of pattern matching tool that allows us to look for string patterns, so patterns of characters, whether they're letters or numbers, inside another, a sort of a given cell of data. Now, to make this a little bit more concrete, we're going to actually use a regular expression on start station name. And this is kind of a hypothetical, like the things we might want to find out about these start station names. So, I like to use as an example, what if we had the question of how many stations are there, how many city bike stations are there on Central Park West? Well, at first this might seem like an obvious question to answer because I can just scroll down here, and because this is alphabetized, I can say, well, I can see all of the Central Park Wests here. But what this doesn't tell me is whether Central Park West appears in the second half of the descriptive location of these start stations, right? So I see Central Park West. This one is actually a little bit different. One of the nice things that OpenRefine lets me do is it gives me several tools for helping clean up my data and make it more uniform. I can actually just choose edit here, and I can make this Central Park West, and it will automatically update all whatever 200 odd rows that was, so that now I have a uniform pattern for Central Park West. However, if I happen to know, because I've inspected this data set before, there are other instances where Central Park West appears, and I think it is, there we go, West 106th Street in Central Park West. Now the question here is, how would I locate all rows that contain Central Park West without having to just look through all the values? That is the kind of task that a regular expression is very, very good for. And in fact, there isn't another type of sort of technology or program that does what regular expressions do. Regular expressions actually exist across pretty much all programming languages, and while they're not supported in Microsoft Excel, they are supported in OpenRefine. This is a really powerful tool. They're a little tricky to kind of get used to, and so we're going to show some examples here of how you can do a basic one, like finding all of the cells that have Central Park West in them. Now, of course, you could do this as a, using like a find, right? I mean, I could just do a find here and do that. However, that only works if I have relatively few instances. So let's say that I had something, maybe Central Park West appeared 50 times. I wouldn't very well want to go, sort of doing a find through this list and manually including each one, right? So the point here is that we're looking for, the other important point about regular expressions is that they scale very well. We can set up a regular expression that will operate, and it will do this search and identifying of these fields for us in a matter of seconds. Okay, so how do we actually go about doing this? The way that I'm going to test my regular expression is what I want to do. The key thing that I wanted to know about my regular expression as I'm constructing it is whether it is successfully discriminating between content that I want and content that I don't, which is to say, I want to check that it's not just capturing things that have Central Park West in them, but ensure that it is also excluding things that don't. So the way that I'm going to do this is I'm going to actually select a couple of entries here that I'm going to use as sort of my test bed so that I can see as I'm constructing, I can do kind of a real-time test of my regular expression. Regular expressions are, as I said, they're kind of tricky, and so you don't generally want to be writing them blind. Like, you want to see what the results are, and then you can tweak them as you go. So in order to do this, I'm going to now go to Edit Column, and on start station name, because that's what I'm operating on. And I'm going to say add column based on this column. And what we can see here, which is handy, is that in the little preview window, am I getting, no, I'm only getting, oh yeah, no, there's one entry. Okay, so I'm getting two different types of entry, like values, right, that have Central Park West and West something, right? So I have 76th Street and 102nd Street. So I can check as I'm going and make sure that I'm capturing both of those, right? Not just one or the other. But then I have something here that has Central Park North, and I want to make sure that I'm excluding that, right? So I can be checking in real time to make sure that this is operating as I like. So I'm going to call this has CPW test. Very important here that I create a meaningful kind of descriptive column header. And the first thing that I'm going to do, if you notice, is that value, right, is a placeholder here that means the contents of the cell, right? So by default, I'm saying this is the current column. This is the column that this is the original column. This is the column that I'm currently constructing. So right now, if it just says value, it's just going to duplicate the values. So I want to ask it to do some work on this. So I'm going to use a function called value.match. And this is going to be a way to say, look for the pattern that I'm about to describe in the original cell and basically tell me if you find it. Now, we can do this in a very literal sense, which is to say that I can actually take this and I can wrap my content in quotes just the same way I would, for example, if you wanted to search for a specific phrase in Google, you would wrap it in quotation marks to keep it all together. So what you can see is that if I put in, Central Park West and West 76th Street as a whole, then it does, the way that it shows that it has found it is it gives these little square brackets, okay, like a list, like an empty list. If it doesn't find it, then it gives us a null value. A null means nothing was found. And we can again see that it doesn't find it on West 102nd, so this is working fine, except that if that was all I wanted, I would just use a text facet. Now, at first, I might say, okay, well, I can just look for Central Park West, but the problem is that isn't a precise match for what I'm looking for. And this is, I'm looking for a piece that is Central Park West, but also might have other things. And this is exactly where my regular expression comes in. And so the first thing I need to do is I'm going to signal to OpenRefine that I want it to interpret the things that I want it to be matching on the basis of a regular expression rather than a regular string. And the way that I send that signal is I wrap my expression in forward slashes. That is arbitrary. It's just how OpenRefine decides to do it. But I still want to treat Central Park West as a group because it's important to me that I find all of those words and that I find them in that order. And so to do that, I'm going to go back to sort of my math traditions, which is to put round parentheses around them. However, I'm not getting a match yet. And the reason for that is that regular expressions need to account for every single item that appears in this value, every single character that appears in a given value. So the problem here is that while this value, for example, begins with Central Park West, as the regular expression gets to the end, I always think of this as a turtle on a number line, but as the regular expression gets to the end, it's going to say, okay, I found Central Park West, great. And then it's going to look at value and it's going to say, well, wait, there's a space here. And my regular expression doesn't leave any room for spaces, right? It hasn't given that little turtle, right, a way to move forward on a space. It's just kind of stopped. So in order to do that, in this case, I'm going to take a very, very general approach. And I'm going to do two things. So first, I'm going to say, look, I don't care what comes after Central Park West. It can be any character. And the way that I represent any character in this regular expression is with a period. A period means anything you want. Space, number, letter, whatever. But this still isn't working because I have to say how many of them there are allowed to be. So I could kind of just like keep adding characters, maybe, until I've added enough that I've accounted for the West 76th Street. So that works, except, well, it doesn't capture 102nd Street because that has one character more. So that's not a very efficient way of doing this. What I can do when I really don't care how many characters, what characters appear, or how many of them there are, is I can use an asterisk. And what that means is you can give me anything can come after this, or, and this is important, nothing can come after this. The asterisk means repeat whatever came right before it 0 or more times. So it doesn't need to appear, but it can appear as many times as you like. So that's great. I now see that I seem to be doing most of what I hope to, which is I'm capturing both of my Central Park West type values. I am ignoring my Central Park North value. However, if we think back to the other example that I found, we know that Central Park West was the latter part of the station location description in precisely the case that we wanted to find, right? And so in this case, what I'm going to do is I'm going to put a dot and an asterisk at the beginning as well, so that it will hopefully capture those things that start with something else but have Central Park West at the other end. Now, this works fairly well, except that it's not very useful for me to have this Central Park West value as the content of the new column. What I really want is something that says, that answers the question of, does it have CPW, right? Does it have this value? And so I'm going to use a built-in function that will convert my results to essentially a true false. And happily, this is a very good function because its function name is very descriptive. It is not null, okay? And I have to wrap, so you can see that I've got a matching set of parentheses for is not null. I've got a matching set of parentheses for value.match, and I've got a matching set of parentheses, for Central Park West, right? So all of my parentheses are balanced. But what you can see that this does is adding that is not null does exactly that. The values that were null appear as false, and the values that were anything else, right, appear as true. This is also important because we can have regular expressions that match on more than one thing, that find, for example, a letter or word combination or another letter or word combination, or two in conjunction. And so having the true false is a very simplified way of presenting that. So I could do this, what I'm going to do here actually is, instead of running this, right, I've now tested out my regular expression. Instead of running this, I'm actually going to close this out. I've copied this to the clipboard. And I'm going to come back here and I'm going to deselect my test values, right? Because I want to apply this regular expression to the entire data set. And so I'm going to now come back here and say edit column, add column based on this column, and paste in my regular expression. I'll now call it has CPW. I click OK. And now I can do a text facet. And if I come down here, I can select the ones that match on true, and I can see that I have in fact captured not just one, but two other start stations that have Central Park West in them. So again, this is a relatively simplistic example. We'll look at some more complex ones next week, but this is a really, really powerful technology and great thing to get comfortable with going forward. So we'll come back and look at another couple of features of OpenRefine. I will see you soon.